another reason that the X-ray detector was responding. Not all hardware works the way you hope it would work. Us theorists have a problem with that sometimes. Okay, so for the charge emission we were considering a mechanism that looks something like this, that if we can upconvert, perhaps we can upconvert some of the charge from conduction electron bands. Copper has an oxide on the surface, and the idea is if we could get some upconversion from the conduction bands, we could get to the oxide. Those levels are much closer to the vacuum level. And if we can upconvert, perhaps we can get some charge to come out. This is the mechanism under consideration. I note that in Carboon's experiment, he saw electron emission, very significant electron emission. So given the headaches we had with the X-rays, there was concern as to whether the charge was real or not. So I was interested in having there be a gold standard test. So the idea is with the RF present, we were running experiments at MIT, and we found noise in every single detector. The amount of noise was more than any of us were familiar with. So the question is perhaps at SRI we had the same problem. So the idea was to use a simple capacitor to see whether the charge signal could actually charge up a capacitor. So we consider this to be our gold standard test. So the requirement was that it pass this test before we submit the abstract. So the idea is to take the electrometer out, put a capacitor in, and charge the capacitor. So the experiment passed this gold standard test. Fran put in a microfarad capacitor, turned the drive on, and watched the charge accumulate linearly in time while the RF drive was on. The current measured was consistent with the amount that was measured by the electrometer directly. Off of resonance, much less current. Charge up capacitors and pass the rated voltage and fry them. And I mean, any gold standard test has to involve the sacrifice of electrical components. And once the test was passed, the abstract got emailed off to ICSF 19, approved, and we were slated to give a talk. We were celebrating. And Fran's the kind that if he's got a good gold standard experiment, do it again and be even twice as sure. This time, the idea was to have no electronics touch anything having to do with the capacitor while the drive was on, mostly for reasons of superstition. This time, the microfarad capacitor showed no voltage, no observable voltage at all. The experiment was repeated with an 8 picofarad capacitor. That capacitor showed charging up to 8 volts, up to 5 volts in 250 in 250 seconds, and up to 8 volts in 500 seconds, with an experiment where the drive was interrupted for the intermediate measurement. So linear accumulation of voltage was observed. I note that this level of voltage is 3 orders of magnitude higher than what we found for an equivalent version of the experiment done at MIT with a dielectric capacitor. If this happens to be real, even though it's not a big capacitor, not a giant signal, this is still a very big signal relative to the system. And if it is real, it's a very, very important result. I don't know whether the signal's real. Also, we've not explored whether it's correlated with the vibrational resonances. We don't know yet if we get no signal off of resonance and a signal on resonance. If it passes that test, it will be a tremendous, in spite of all of the headaches, it will be a tremendous and thunderous result. We've tried experiments at MIT, as I've mentioned, we saw a lot of noise, but we didn't see signal. So retrospection, we know that there's noise. We also know that the X123 detector can give false signals. We saw harmonics up to 10th order from our linear amp at MIT. Somehow the noise got into components that didn't seem to have anything to do with the rest of the circuit. I was very impressed. The gold standard test SRI may signal a real